Good afternoon, everybody. So let us start our class. So we were discussing thread and multi-thread programming. So we know that a thread is a program's execution path. In an application or in a program, we can have multiple execution paths to execute multiple modules or multiple programs in our application, right? So we already know how to create a thread in Java by extending the thread class or by implementing the runnable interface. We know that how to create a thread and how to start a thread by calling the thread method, and that will actually start the run method. And we went through some live programs. Then we discussed thread lifecycle. Did I discuss thread lifecycle? Yes. Right? Okay, that's good. A thread has your question.
It was after class I thought about it. So if one thread were to access a variable, right?
One thread.
If one thread were to access a variable, right? Dexter said if another thread were to access the variable, it would, like, if they were trying to change it, it couldn't change it until that thread was done.
Yeah, that is the thing we will discuss today, thread synchronization. Okay, controlling threads and thread synchronization. I will go through there, but just before I go there, let me recap the thread life cycle for a minute. Okay, a thread has 5 states, newborn states, just when a thread is created. Then when a thread is created, then it's not ready to run yet. It needs to call by the start method. So when a thread actually is ready, or means the active thread has 2 states, actually runnable or running state. When a thread is called by start method, then it goes into an active thread status, that is either runnable or running state. At any point, whenever a thread is running, that is the thread actually running thread. Okay, and then at any point when a thread is running, we can call the yield method to send to the thread to runnable position. Runnable means it's not running but ready to run. Okay, but if you want to suspend a thread for a certain time, that is we call sleep method. By calling sleep method, we can suspend a thread for a certain time. And if you want to suspend it for a time until another event occurs, that means another thread executes, finishes execution, something like that, then we call suspend method. And then when a thread becomes suspended, you can resume it to make an active state, or you can kill it or delete it. When a thread is called stop method, then the thread is deleted. We cannot call this thread again any more time. That is deleted. Okay. So then the last thing today we will discuss thread synchronization. Thread synchronization is an important task in order to execute multi-thread programming synchronously. You know, while running something, we have 2 modes. In general, we say synchronous mode and asynchronous mode. In general, public understand this. Likewise, like online or offline. So if something is offline, that means you can do it at your convenient time or according to the schedule. And online means you have to do it right away. Whenever it's something up or online, you have to do on right thing at right time. The synchronization is something like, for instance, you have to do online, right time. Okay. Asynchronous means, for instance, something is offline that you can do at your convenient time, or sometimes people say asynchronous mode. That means you can have some variation. but we have to maintain the schedule or deadline. But within the deadline, you can do that thing. For instance, your assignment submissions are asynchronous. You can submit within the deadline, right? But your class, when you attend in a face-to-face class, that is synchronous. If you do not come on time, then you will miss the class, right? A live class is a synchronous mode, but an assignment submission is asynchronous mode or offline mode, although we say. Okay. So synchronization is needed. It's very important. For instance, without synchronization, deadlock may happen. Okay. For instance, let me give you an example. Deadline occurs many times. For instance, when a thread needs something else, some other resource that is being used by another resource, and until that resource is released by the second thread, first thread will not be able to get that. So in that situation, there may be a deadlock situation. So let us consider that a deadlock situation, right, in a way. For instance, two of you, okay, for instance, you and your friend, okay, and in a restaurant, in a dining table, so you got some food, you and your friend, you are there, okay. So you got some food, and you got a spoon, and your friend has a spoon or fork. But you got some food. In order to eat that food, you need two spoons or two forks, or maybe one spoon and another knife. But you got only one knife. Okay. So without the knife, none of you can eat, right? So like this is you, okay, and this is your friend. So if you get the knife, okay, then if you have the knife, then you will be able to eat, right? And your friend cannot eat. Your friend cannot eat, okay? But think about the situation, okay? So if your friend tell you something, if your friend knows some information that is secret, your friend tells you that, okay, I will tell you some secret if you give me the knife or give me the knife, okay? And then, but if you tell your friend, then okay, I will give you the knife if you tell me the secret first. So both person are adamant, okay, stubborn. Nobody wants to lose. In that situation, there will be deadlock. So until you release the fork or spoon, your friend will not be able to eat, so then he will not tell you the secret. And on the other hand, until your friend tells you the secret, you will not give him the spoon or fork. So in that situation, there will be a deadlock. Until maybe you have to pay the bill or you have to pay fine for killing their time. But this is a deadlock situation. So this type of situation happens many times in many systems, may happen in many circumstances in application or in a programming. For instance, if one thread is using a data file, okay, that will be needed by another thread to execute something, but that until that thread executes something, the first thread cannot be able to release the file. So in that, just this kind of situations, a deadlock may happen. Okay. So in order to avoid this kind of deadlock situation, okay, so your multi-threading programs need to be programmed wisely so that a deadlock does not happen. Or if it happens, then it can be unlocked after a certain amount of time. Okay, in Java and in C Sharp, there is a class controller. It's called monitor. This monitor holds this monitor. Whoever thread holds this monitor, that thread becomes active in order to do something. Like this monitor is like our spoon or fork. Whoever has the fork, he will be able to eat. Okay. So in the few programs, I want to give you some like just just some basic idea about how to manage threads and control synchronization or managing deadlocks, something. That program 13. So let us see this program. Okay, this is a very simple program. Okay, but I believe until how many of you have had a chance to download my code from my GitHub account and then to run and play with? One only. Phoenix. So let us give her a big clap. Okay. Okay, she is the only one. Okay, so until I'm telling you that unless you do practice this, play with this program, you will not be able to understand this. Even if I spend my whole class, it will be difficult for me to teach at this point. Yeah, there are C# codes. I will go to C#. Let me finish this code. So in this program, if I run this program, okay, so then please give attention that what will be my output. Did you notice that when I'm running program, it is waiting 3 seconds to display my closing parenthesis? Did you notice that? Again, let me run it again. You will see that first time, as soon as my program runs, then it will print this part. And then it will be waiting until to print like this one 3 more seconds. Until to print this 3 more seconds. It will be waiting, okay? Yes.
So I have a really slow computer, right? Would it still be 3 seconds, or would it like
300 milliseconds, that means 3 seconds.
Right, but if your computer's slow, right, would it still be 3 seconds?
So here my computer is connected with my WebEx through my internet. So it is connected to host computer and server, and then with that server it is connected to the podium computer. So it takes some time to run it to see me here and on the screen.
No, I was saying my computer itself.
Okay.
Right, it's really slow. My computer is bad. Would it still wait 3 seconds? Like
it will wait still 3 seconds, but actually if your computer is slow, then you will not be realize that when it started.
So like, well, saying if it takes 2 seconds to run a process, right?
Yeah.
Let's say it takes 2 seconds normally to output it. would it be 5 seconds or would it still be 3 because it already counted the 3 milliseconds?
Did you take the computer organization class? Do you understand latency?
Yes.
Latency.
Yes.
What is latency? Latency is time. Is time to. What is latency?
Between when it goes around, right? Between when.
Latency is the waiting time in order to execute an action. Okay, that is the debate and concept beyond this my class. Okay, the computer organization. But let me show you. Give your attention to the CC that almost 3 seconds is taking 3 seconds. How do you count 3 seconds? 3001, 3002, 3003. Okay, so that I have this program. Okay, so that it is waiting 3 seconds in order to print this. Okay, so this program has synchronize keyword. If I do not use this synchronize keyword, let me keep this program everything same except this synchronization keyword, and let me run this program. Do you see any difference in the output? Okay, that means this program is not synchronized. Okay, so in order to synchronize in Java, okay, so in programming it says a little bit the slide, we need to use synchronize keyword. In Java there are two ways to do synchronization, either by putting the code in a synchronized block or by using the synchronized keyword. Synchronized is a keyword. So when we I will come back in C# lesson. Let me finish it, please. So in Java we use synchronized keyword. Okay, so if I use synchronized keyword, then it's fine. If I run my program, then it is synchronizing with my time, and then okay, people who are intended to develop game in your senior years, then you should give focus on synchronization and parallel processing. In our after the break, we will discuss about parallel processing. You should get some interest in parallel processing. But if you do not understand synchronization, then you will not understand parallel processing. So I will advise you to spend some time during your break to understand this multi-threading. I will upload all of these lecture videos, okay, and then I will upload all of my programs code. Then please get this and then spend some time to play with this so that you understand. Then you will get actual interest in parallel processing. Otherwise, just wasting your time. Okay, so let me go through in C#. Passing out my resignation. Please everybody sign on that, please. Okay. Okay, I have an example of thread synchronization example, two examples. Thread synchronization example 1 and example 2.
Yeah, everyone else got it already. Everyone else already got it.
Okay. So everybody's signed on this? Okay, so let me see this program, what this program says. Okay, so this has sleep actually 1 second. 1 second does not do. Let me do it 3 seconds. Let me do it 2 seconds. Okay, so if you do not give attention, then I will finish this class. I will wrap up. What do you like me? If you do side talk, okay. Okay. What are you talking about? Please speak loudly so that we can.
So would synchronous, would that, if you didn't do sleep, right? Would synchronous do it just like instantly?
No.
No?
Sleep is just waiting to see the effect, how the next state is coming. Let me run it. So I did not run this program, so I think you did not realize what will happen. So here in my main method, I have just this line. It will print this one, then it will just select it, set up the thread name as my main thread, and then it's created a new thread, child thread, and child thread name is child. Okay, and in my main method it is counting 1 to 5, make it 25, so that okay, 1 to 5, 0 to 5, and after every 2 seconds it is calling the thread name. Main thread name will come 5 times after 2 seconds each, then main thread terminates, and then it will go to the child thread, and child thread will display its name after every 3 seconds. Okay, this is, let me see. Let me see. Maybe I played with this code yesterday. Maybe I deleted some stuff. I'm looking where is my synchronization code. Yeah, I'm looking for that. Let me go to the another. My log. Okay, my code is not complete. This program is asynchronous. Okay, I will get the complete code. Maybe I deleted some codes, some block. So in our next class, I will get the code. I will fix the code. Okay. And let me see. I have another program. Let me see what it shows. Where's my output? Okay, in my next class, I will get some synchronization pair with C#, but there are some. You see how many courses I have synchronization? One, I have project one. I have multi-threading, another one, two. I have three. Okay, at least these three projects are working. So if you play with this one after the break in my next class, I will get some code about thread synchronization with C#. Okay, anyone has any question? Okay, one of the important programs that thread killing a thread, destroying a thread. I'm not sure I discussed with this one with you. So this program is a thread management. So that is in Java we use stop method to kill a thread, but in C# we use abort method to kill a thread. So once you kill a thread, you cannot restart that thread. This program, if I run this program, I should get an exception. The exception is because on this line I had deleted the thread, destroyed the thread. So then after that I cannot start the thread. So this is why the error is showing that over here. But if I do not abort it, then I should be able. Did I run this? Set this one?
So it's already running up there, right? So you just can't hit start twice.
Oh, sorry. Here, due to my monitor, I don't see. Okay, it is running.
Oh, yeah, because it's doing dot start twice.
Is it starting twice?
Yeah, so on line 42.
Oh, yeah.
I tried.
Okay, let me go to the last two slides. The last slide is from, this slide is from, that is thread output from a gaming program. The professor who developed this course, he ran his one of his applications or game program, and then he traced that output. Okay, another thing that maybe before I forget, I will tell you, there is a thread priority. Thread priority. So you can set up thread priority. That means which thread will be executing first and which thread will be executing last. Thread priority is set up between 1 to 15. If you do not set up its priority, then by default priority is 5. All threads have same priority. but you can set up a thread with highest priority, maximum 15. If you set up a thread with highest priority, then it will be executing first. Okay, another thing is that in C#, in Java, since our very first program, you know that we realized that, for instance, here, if we say object 3 dot sorry, my computer is slow. I want to say that there are some methods to notify and notify wall. You see the notify and notify wall. These two methods are widely used for giving notification to the thread, to the threads. Okay, but these methods are widely used so that instead of putting this method in the thread class, Java put it in object method, object class. So these methods are used widely. For instance, when we use app or some applications, sometimes the developers send us notification, a common notification to a group of people or all users, right? So the notify wall means you are sending common notification to all users, and notify means to a specific thread.
So what is notify?
Notify to something to when there are multiple threads running or in the queue. If you want to notify something, give a message.
So like enter new data?
Whatever message you needed, but I'm telling that please do some practice, and then when you do practice, and this is not the end of this topic. This is the startup. This course is aimed to give a startup of multi-threading. So that just if you remember that it is possible to do multi-threading programming in Java and C#. And then when you go to your senior level data structure course and programming and algorithm course, and then you will understand the other stuff, how to do that. Okay, anyone has any question? After the break, we will discuss parallel processing. Okay, and have a good break, everybody.